In this lesson, we're going to be solving two-step linear equations in one variable. A linear equation in one variable can be written as ax plus b equals 0, where a and b are just constants, they're just numbers, and x is the variable of my equation. When I'm solving a linear equation, I could have three possible solutions. I could have one solution, so that means x equals some number. I could have no solution, which means that I would actually have a false statement, something like, say, 5 equals 3. I know that's not true. That means that my equation would have no solution. Or I could have infinitely many solutions. So that would be something like 5 equals 5. I know that's a true statement no matter what. It doesn't matter what the value of x is because the equation will always yield 5 equals 5. When we are solving two-step equations, we don't see really a no solution or infinitely many solution type of answer. We generally will just see one solution. When we move on to the more complex types of equations where we have to use the distributive property, or we have to combine like terms, or we have variables on both sides of the equal sign, that's when we'll see examples of no solution and infinitely many solutions. But those will be in the next videos to come. The steps to solve a linear equation. Now this is true for any linear equation. We would clear any fractions we can by multiplying by the least common denominator. There are other ways, depending on the type of equation we have, to start off this first step, but generally we want to get rid of the fractions in the easiest way possible. If we need to, we're going to apply the distributive property to clear any parentheses, combine any like terms. So steps 2 and 3 we practiced in our simplifying expressions video. Then we want to isolate the variable and check the solution by substituting into the original problem. For two-step equations, we actually start off with step number 4. We start by isolating the variable, and then we'll check our solution. So let's start off looking at a problem. Here I have 3x plus 5 is equal to 20. So if you remember our order of operations, we would do parentheses, exponents, multiplication and division, and then addition and subtraction. When we're solving an equation, we kind of want to undo the order of operations. So we want to peel back the operations to get that variable isolated. So the first thing that we would do is we would subtract the 5 from both sides. So I have 3x is equal to 15. I have my x term isolated. I need to get x completely isolated by getting rid of that multiplication by 3, which we'll do by dividing each side by 3. So we get x is equal to 5. So in this first example here, I'm going to show the check. In the subsequent examples, I'll let you do the check on your own. Remember, when we check, we go back to the original problem. The reason being is you could have made a mistake at any step in the process. We won't know if there's a mistake unless we check the original problem. So we have 3 times 5 plus 5, and we want to make sure that it equals 20. Well, we know 3 times 5 is 15, and 5 plus 5 is equal to 20. So we get that our solution checks. Let's look at this next example. We have negative 4 minus x is equal to 16. There are a couple ways that you can actually start this problem, but the way that we're probably most familiar with is distributing the negative sign. Remember, that's just like multiplying by negative 1. So I have negative 4 minus a negative x, which gives me a plus x, because I know negative 1 times negative 1 is a positive 1. And that's still equal to 16. I want to isolate x, so I'm going to add 4 to both sides. So x is equal to a positive 20. Again, we would check by plugging in 20 into the x in the original problem. Our next example, we have x plus 9 over 3 is equal to 8. Again, there are several ways that we can attack this problem. We can start by multiplying through by the LCD, which is 3, because there's one fraction here. Or since we have a proportion here, one fraction equal to another fraction, I could cross multiply. They actually end up doing the exact same thing, whether you multiply by 3 or cross multiplying, we're still just multiplying to get rid of that 3 in the denominator. So I'm going to multiply everything by 3 over 1. So this 3 cancels. 3 times 8 is 24. That's equal to x plus 9. Subtract the 9 from both sides. X is equal to a positive 15. Our last example here, similar to the previous one, except now I have a fraction in its own term. So I have negative 6 is equal to x over 2 minus 10. So again, we could start by either adding the 10 over to both sides and then multiplying by the 2, or you can multiply by the 2 first. I think most of us are more familiar with starting by adding the 10. So I have a positive 4 is equal to x over 2, and just like before, multiply by the 2. 8 is equal to x.